I want to solve this differential equation. So the first thing I'm going to do is move over ty times dy to the right. And then, so I want to get it in terms of dy over dt. So I'm going to divide by negative ty and dt. So we end up having dy over dt equals negative y squared plus e to the t over ty. And I'm going to break up the fraction. So there's a common denominator of ty. So the numerator will be negative y squared and negative e to the t. Move over the y squared over ty. And the reason we're doing all this is because we want to compare it to a Bernoulli equation. The Bernoulli equation has a standard form of y prime plus p of ty equals q of t times y to the n. Here p of t is 1 over t, q of t is negative e to the t over t, n is negative 1. For Bernoulli equation, we let v equal y to the 1 minus n. And here we set as negative 1, so v is equal to y squared. In order to solve the Bernoulli equation, we need to solve 1 over 1 minus n times v prime plus v over t equals negative et to the t. So plug in n equals negative 1. And here, I want to have v prime by itself, so I'm going to multiply both sides by 2. At this step, I want to find the integration factor. And for that, we're going to take e raised to the integral of 2 over t dt, and integrating it, we end up getting t squared. So we're going to take t squared and multiply both sides with it. So we end up having t squared times v prime plus 2t times v on the left, which, if you make the connection, the derivative of t squared is 2t, the derivative of v is v prime. So this is really the product rule of t squared times v. And now we would have to integrate both sides. Okay, so the integral is going to cancel out with the derivative on the left, and on the right we will have to use the integration by parts. So now we have to solve for v by dividing both sides by t squared. But in the beginning, we said v was y squared. That's a substitution we made. So let's put in y squared in for v to get this. And now let's handle the initial condition that y of 1 is negative 2. So let's plug in negative 2 in for y and 1 for t. So when we do that, we get c is 4. Okay, so this is what we have so far. We have in terms of y squared. But I want y. So I'm going to take the square root of both sides. What happens when you take the square root of a square? Well, you get the plus or minus. So a lot of students will just put plus or minus the square root. But in this case, it's wrong. Because when I plug in t is 1, I need to get negative 2. The square root is always greater than or equal to 0. So if I want to get a negative answer, when I plug in 1, the outside has to be negative. Because if I was to plug in t equals 1, I would end up getting 2 if the outside was just plus. So therefore, we're going to keep the negative sign. And that is our final answer.